Hello everyone and welcome back to our videos. Today our video will talk about something important and something cause the aircraft to make lift, and this thing is the airfoil shape. The airfoil shape is contain the shape of the wing, and because of that the air will slipstreaming on the upper and the lower wing, and the air on the upper wing it will be faster, and that will make the aircraft to make lift. Also we will talk about the components of the airfoil shape, and we will talk about something called stool and the causes of the stool. At the beginning, an airfoil is any surface such wing or propeller that provides aerodynamic force when it interacts with a moving stream of air. As we see here in this figure, this is the airfoil shape of the wing. In this airfoil shape we have a component. The first component is the chord line. The second component is the angle of attack. The third component is the leading edge. The fourth is the trailing edge, and we have the camber. Now we will define every component individually, and we are gonna start with the leading edge. Leading edge, this part of airfoil meets the airflow first, and that means this area is the leading edge. Trailing edge, this is the portion of the airfoil where the airflow over the upper surface joins the lower surface airflow. This the trailing edge, and the air that comes from the upper wing and the air that comes from the lower wing, it will meet in this area and in this point, and that's called the trailing edge. Chord line. The chord line is an imaginary straight line drawn through an airfoil from the leading edge to the trailing edge. And as we see here in the blue arrow, this the chord line, and you have to put this in your consideration. They said it's an imaginary line. Camber. The camber of an airfoil is the characteristic curve of its upper and lower surfaces. The upper camber is more pronounced, while the lower camber is the comparatively flat. This causes the velocity of the airflow immediately above the wing to be much higher than that below the wing. As we see here, this our upper camber, and here the lower camber. After that we have the relative wind. This is the direction of the airflow with respect to the wing. As we see here, the wind that will cross the airfoil shape, or it will goes in front of the wing. If a wing moves forward horizontally, the relative wind moves backward horizontally. Relative wind is parallel to and opposite the flight path of the airplane. After that we have the angle of attack, and this is the most important thing. You have to keep it like the back of your hand. Angle of attack, this is the angle between the chord line of the airfoil and the direction of the relative wind. As we see in the figure, the angle of attack, it will be drawn between the chord line and the relative wind. We still have two things you have to put in consideration about the airfoil components, and they are the wash up and the wash down. The wash up is the deflection of the oncoming airstream upward and over the wing. The downwash is the downward deflection of the airstream as it passes over the wing and past the trailing edge. After we understand the components of the airfoil shape, we will understand now the changing of angle of attack. If the angle of attack change, what will happen to the airplane? Pilots have direct control over angle of attack during flight at normal operating speeds. If a pilot increases the angle of attack, lift increases. That means the pilot will take the control column or the side stick to the aft position, and this will make the angle of attack to change, and when the angle of attack changes to up position, the lift will increases. The angle of attack is changed anytime the control column, as we said, or the joystick or the side stick is moved fore or aft during flight. At the same time, the coefficient of lift is changed. The coefficient of lift is a way to measure lift as it relates the angle of attack. Center line is determined by wind tunnel tests and is based on airfoil design and angle of attack. Every airplane has an angle of attack where maximum lift occurs. As we see in this figure, we have when the angle of attack changes to down position, that means the lift will decrease. But when the angle of attack increases, that means the lift will increase. Now we will talk about stool. A stool is caused by the separation of airflow from the wing's upper surface. This results in a rapid decrease in lift for a given airplane. A stall always occurs at the same angle of attack, regardless of airspeed, flight altitude, or weight. This is the stalling or critical angle of attack. It is important to remember that an airplane can stall at any airspeed, in any flight altitude, or at any weight. To recover from a stall, smooth air or smooth airflow must be restored. The only way to do this is to decrease the angle of attack to a point below the stalling or critical angle of attack, as we see here in this figure. The angle of attack will increase and the separation starts. After that, the angle of attack still increasing and the separation will move forward. After that, when the angle of attack reach to the critical angle of attack, the airfoil stalls, and here the airplane it will moves to stall. To prevent stall, we will study that on the airframe book. We have many ways, like we have slot or slats, and this will make some air to flow to the upper wing and to the lower wing, and will help to decrease the stall, while the pilot will interact or will give the command to decrease the angle of attack and to prevent the stall. Changing airspeed. The faster the wing moves through the air, the greater the lift. Actually, lift is proportional to the square of airplane's speed. For example, at 200 knots, an airplane has 4 times the lift of the same airplane traveling at 100 knots, if the angle of attack and the other factors are constant. On the other hand, if the airspeed is reduced by 1/2, the lift is decreased to 1/4 of the previous value. Angle of attack and airspeed. When speed decreases, the angle of attack must increase to maintain the same amount of lift. Conversely, if the same amount of lift is maintained at a higher speed, the angle of attack must decrease.